All right, hello again. I'm on page 457 in your SpringBoard book, and this is starting right after number 6. It doesn't have a number here, but it says the graph of the function y equals x squared minus 6x plus 5 is shown below. So we are moving away from that Trebuchet example, and we're moving into a different quadratic and kind of going to go through the whole thing again with how to factor and find the zeros of the function, or the solutions to the quadratic function, okay? All right, so first off, if you just take a look at the graph right here, there's several things that we can point out that we know about the graph, and then we're going to kind of walk through them on these questions right here. So number 7 tells us to identify the x-intercepts of the graph. Well, that's the points where our graph crosses the x-axis. So we have one right here, okay, and what's the ordered pair for that one? It would be 1, 0, so that's one of the places, that's one of the x-intercepts. The other one would be right here at 5, 0. So this quadratic has two solutions, all right? It's got two solutions, or two zeros of the function, at 1, 0 and at 5, 0. Number 8 tells us, or asks us, what is the x-coordinate of the vertex? So the vertex is either your minimum or your maximum point. This one has an a value that is positive, which tells us that the quadratic opens up, and if it opens up, it's going to have a minimum point. So your vertex is right here, that's your lowest point on the graph, and it wants to know what's the x-coordinate of the vertex, right? So the x-coordinate of the vertex right here, what is it? It's a 3. It's a 3, okay? Number 9, describe the x-coordinate of the vertex with respect to the two x-intercepts. So it's saying, how is this number 3 related to the x-intercepts of a 1 and a 5, right? Well, what do you know about 3 in relation to 1 and 5? If you look at it on the graph, it's really easy to see that here at 3, we've got the x-intercept here. It's 2 units away from 3. And this 1 is also 2 units away from 3. So what they're wanting you to see is that the vertex of this function is halfway between the two x-intercepts, okay? It's like it's the middle point. Or another way of looking at it is it's the average, right? It's the average. Like if you found the average of 1 and 5, right? How do we find the average? We add the two numbers together and we divide by the number of numbers, right? So 1 plus 5 would be 6. 6 divided by 2 is 3, okay? So that would help us find the x value of the vertex of the function, okay? All right, so we did all of that by using the graph. Ooh, by the way, what's the y-intercept of the function? Look right here. Look at that, the y-intercept. That's a positive 5, isn't it? Well, look, our quadratic is in standard form. See? Literally, C. It's C in your quadratic right there. C is 5. It tells you that right there. That is so amazing. I love it. Okay, so now looking at number 10, we're going to start to do some of this work using algebra instead of using the graph of the function, okay? It tells us to factor the quadratic expression, x squared minus 6x plus 5. So they gave us the graph. Now we're going to factor it, okay? Remember, first thing, always look for the GCF. Is there anything that we can factor out before we start to factor this function? It looks like our GCF is 1 because look, we've got a coefficient of 1, negative 6, and then a constant of 5. Well, the GCF of that would be 1, and then only the first two terms have an x in them, so we can't factor out any x's. Our leading coefficient is 1, so we don't need the chart method. We can go straight to factoring into the two binomials. So I've got x is the first term in both binomials. I need factors of 5 that add up to negative 6. All right, so factors of 5, what are my options? 1 and 5, 2 and 3. Well, 2 and 3 are not going to add up to 6, but 1 and 5 will add up to 6, right? And if I need the last term to be positive, then and the middle one to be negative, then both of these terms need to be negative. All right, so I'm going to have x minus 1 and x minus 5. And of course, you can redistribute that and see if that gives you the original quadratic, okay? Each of the factors that you found in part A is a linear expression. Solve the related linear equation for each factor by setting it equal to 0. This is the step I showed you before. We're going to take each one of those binomials and set them equal to 0. I'm going to do the work over here on the side. So x minus 1 is equal to 0. Let me take off that parentheses right there. And then x minus 5 is equal to 0. Okay? Solve them both for x. So I get x is equal to 1. Add 5 to both sides here, and I get x is equal to 5. Okay? SpringBoard is wanting you to see that these are some pretty important numbers. We're going to relate that back to the problems with the graph that we just did. Okay? All right, let's come over here to see. So, well, under B, I'm going to put x is equal to 1, and I got x is equal to 5. Okay? C, solve the related quadratic equation for the expression in part A, that is, solve x squared minus 6x plus 5 is equal to 0. Okay, well, we just did that. Interesting. Okay, that was weird. So, solve the related quadratic equation for the expression in part A, that is, solve. We did that. Why are they asking us to do that again? That's kind of weird. All right, well, we've got our two equations already. So we've got x is equal to 1 and we've got x is equal to 5. Maybe we just did it in an extra step. Okay, sorry. This is part C right here. This is part C right here where we actually solved. In part B, it just told us to set them equal to 0. And then now in part C, it wants us to solve. Okay, so we got a little bit ahead of ourselves. And by we, I mean me. All right, sorry about that. Okay, so then go to 11. 11 says, how do the linear factors of x squared minus 6x plus 5 you found in item 10a, that would be right here, how does that relate to the x-intercepts of the graph of the function y equals x squared minus 6x plus 5 shown above? So here's where they want you to have your light bulb moment, right? So we're getting answers. When we factored, we're getting answers of x minus 1 and x minus 5. What they want you to see is that if I factor versus graphing the function, say that you graphed this in Desmos, like you took this entire function and you plugged it into Desmos, and you look to see what the x-intercepts are, x-intercepts of 1 and 5, you're getting the same answers. That's what we're wanting you to see, is that whether I use graphing as a method of solving or if I use factoring as a method of solving, I'm going to get the same answers, okay? Now it says B, without graphing, how could you determine the x-intercepts of the quadratic of this quadratic function? And then now they're giving us a different quadratic function. So they basically want us to test this out with another point, which we can do. We can do that pretty easily. Let me get some scratch paper over here so I can have some more room to work. So I'm going to take you through this process again, and I'm going to use a different function, okay? All right, so I'm going to take the entire function, x squared plus x minus 12 is equal to 0, and I'm going to set the whole thing equal to 0 instead of equal to y, just so that I can factor it out. Okay? Check for your GCF. If your GCF is 1, which it is in this case, then go ahead and factor into your two binomials. Okay? Our leading coefficient is 1. So we're going to go ahead and just look for factors of negative 12 that add up to 1. Factors of negative 12 that add up to 1. Okay? So what are my options? I've got 1 and 12. I've got 2 and 6. I've got 3 and 4. I think 3 and 4 are the ones that are going to help us here. So my last term needs to be negative and my middle term needs to be positive. That means my 4 needs to be positive and my 3 needs to be negative. So let's go ahead and write our binomial. So x minus 3 and then x plus 4. All right, folks, we've been doing this for weeks, this part right here. The only part that's new is where you're going to take these two binomials, set them equal to 0, and solve for the x-intercepts. Add 3 on both sides. We get x is equal to 3. Subtract 4 on both sides. We get x is equal to negative 4. These are your two x-intercepts. If you wrote them as ordered pairs, it would be 3, 0 and negative 4. 0. Okay, that's where they're going to hit the the x-axis. So at +3, and the other one at -4. I know it opens up. It's gonna look something like this. Okay, my really rough, ugly sketch right there. Sorry about that. Okay. All right. You definitely need more practice with this, so you should be going to, let's see, page 458, numbers 13 through 16, this right here, the check your understanding. Work those out. Please do them. It's probably best if you do them on a separate sheet of paper. Take a picture of it and email it to me when you are finished. Bye.